Arithmetic sequences. An arithmetic sequence is a sequence that has a common difference between each term. That common difference is usually called D. The first term is A, usually that's a subscript 1. And then we talk about the number of terms being N. So if we look at each term in a row, we start off with one that's just A, and then we've added D once. And then if we add D again, what we've really done is added 2D, and we go up, and so if here is N, this is 1, this is 2, this is 3, we notice that the number of D's we added is 1 less than the number of terms. There you go. So we can check to see if this is an arithmetic sequence by taking each term and subtracting the one that came before, and making sure you get the same answer each time. There's a recursive formula and an explicit formula for the arithmetic sequences. The recursive formula takes a sub n minus 1. So that's the previous term. And adds the common difference. We can't do this unless we have at least 2 starter terms, so we can't do it with less than 2n. For the explicit formula, that helps us find any term in the sequence. All we need to know is the first term and the difference. And then we can find the value at the nth term. So we'll go ahead and start with ones that are definitely arithmetic. I can do a double check real quick. -2. There we go. -2 minus -6 is equal to +2. +4. 2 minus -2 is equal to +4, etc. But we don't need to keep doing that. So to use the recursive formula, we need to have our starting value. Okay, so let's take these 2 arithmetic sequences. We know they're arithmetic because they have the same common difference between each term. And we're going to write the recursive formula and the explicit formula. So the recursive formula, we're going to say that a sub n is equal to the previous term plus the common difference. So the common difference here is 4. The explicit formula, a sub n equals, we need to know what the first term is, so just for the sake of argument, we'll pick the first term that we see. And then we're going to add to that the n minus 1 times whatever the common difference is. So I should really give myself a little bit more room here. Alright, let's try the other one. Let's do the recursive formula. The nth term is equal to the n minus 1 term plus the common difference. And for the explicit formula, we have our starting term multiplied by the common difference times n minus 1. So we need to know whether or not the following three sequences are arithmetic, and if so, we're going to look for the 100th term. Let's start off with this first guy right here. Okay, so we just kind of looked at this one. We know that the common difference here is 4. So d equals 4, and we want to know the 100th term. So we know the 100th term is equal to -6 plus the common difference times, in this case, 100 minus 1 is 99. And we get an answer for the 100th term of 390. So let's look at the next one. We haven't seen this one before. If I take the first two terms, subtract, I get -24. And then if I subtract these two terms, I get -12. Here I get -6. So since I haven't gotten the same difference each time, this one's not arithmetic. Let's take a look at the one with natural logs. The natural log of 6 minus the natural log of 3 is really the same thing as the natural log of 6 divided by 3, which is the natural log of 2, which is kind of an interesting result, but as long as I get that same result each time, we can call it arithmetic. So let's take a look the next time. And we get the same difference, so our common difference must be the natural log of 2. I'm going to erase that, so pause it if you need to write anything down. So our common difference is the natural log of 2. So to find the 100th term, we're going to take the first term plus 99 times the common difference. You write it that way. And we get a 100th term of Okay, so let's take a look at these three. We already know the first one's arithmetic because we've already looked at it. If we want to find the 100th term, we're going to use an explicit formula so we don't have to find 99 other terms. So, in this case, the 100th term is equal to our first term plus the common difference times n minus 1. And we get an answer of 390. Down here, if you take a look, you'll notice that as I go down the terms in the sequence, I subtract 24, and then I subtract 12, and then I subtract 6, so this one is not arithmetic. When we do the natural logs, though, the natural log of 3 minus the natural log of 6, actually I should write the other way. Using the properties of logs, we can actually reduce that down to the natural log of 2, and that'll happen again with the next one. So we have a common difference in this one of the natural log of 2. So pause this if you need to jot that down because I'm going to erase it. So what we have here, common difference of the natural log of 2. To find the 100th term, take the first term, and we're going to add to it the common difference multiplied by n minus 1. And using our properties of logs again, this is really equal to the natural log of 3 plus the natural log of 2 to the 99th. Okay, so now that we have a clean slate, let's just look at that again. And here I have my properties of logs up at the top. We already said that our common difference is the natural log of 2. And let's see, we're going to take the 100th term, which is equal to the first term, plus the common difference multiplied by n minus 1. So when we have a coefficient of a log, which this really is, we can rewrite this as 99 natural log of 2. We can rewrite that as an exponent. So this is really the natural log of 2 to the 99th. And this is the natural log of 3. And we're adding those together. And when you add two logs together, you can multiply the bases of those logs, or not the base. So we can multiply those two together. And then I can take the natural log of that. And we get approximately 69.72. So just one last thing, you might think, okay, arithmetic because we're adding every time, but actually it's called the arithmetic mean or the arithmetic sequence because each term is the arithmetic mean of the terms before and after it. Arithmetic mean is the mean or average you've always taken. So let's take a quick look at that. So let's take any two terms. Let's take a plus n minus 1d. So the terms before it would be a plus n minus 2d and a plus nd. And so if we add these two up, we're going to get 2a plus, and just a quick distribution here, 2dn minus 2d, and I need to divide that by the number of items. That was 2. So when I divide that, we get a plus dn minus d, which can be rearranged as a plus d times n minus 1, which gave us that term right there. So there you go. That's why it's the arithmetic mean.